Hello, my name is Mr. Asprey and I have finished my Edexcel IGCSE predicted papers for the 2025 exam session. This is my paper 1 and this is version 1 because I've actually made 3 versions for each paper, and I'm going to talk for a couple of minutes, so please do listen up about how you can use these papers and where you can find more and all that stuff. So first things first, you can find 2 more versions of my predicted papers if you sign up to my live revision session, which is happening on Sunday the 11th of May. Now, in that session, what I will do is I will go through my 2 papers. We probably won't have time to do all the questions, but any questions we don't go through, I create video solutions for, and there's written solutions for all the questions as well. So if you like this paper, which you're just about to do, then do check out my live revision session, because I've also got loads of good reviews from last year, and also loads of 5 stars as well. So yeah, check it out. It's good fun, and hopefully it will really help you as well get prepared for paper 1, and also paper 2, because I do one for paper 2 as well. And what I've done here is I've made these questions entirely myself, so you won't find these questions anywhere else. How to use this paper, what you need to do is download it from my Google Drive, complete the paper and try and do every question to the best of your ability, and then come back to this video to watch the solutions to see how I would do the question and also any tips that I will give you along the way. So make sure you do that to really challenge yourself. So the papers that I've made are very challenging. I've selected the questions by, as you probably know, I've ordered the IGCSE into 60 topics. So all of my videos on the IGCSE reference one of those 60 topics. And I've just gone through loads of past papers and my experience in IGCSE, and I've picked the 30 topics that I think come up for the most marks just generally across H and HR papers. So that's why I've picked these 30, but of course, massive disclaimer, it does not mean these are guaranteed to come up on paper 1. Of course not, they can come up anywhere or not at all. The best thing to do is to revise thoroughly and to make sure that you're using all of my resources and just doing as much revision as you possibly can for all of the topics. Okay, bosh, let's get into this. So, 3 hours, 30 questions, 150 marks. Subscribe, yes! Here we go. So these questions are made entirely by me. Let's do it. So find the highest common factor between 336 and 120. Show clear working. Don't mind if I do. So 3, 3, 6. I know that's divisible by 3, so I draw 3 here, circle it, and that is 1, 1, 2. That's divisible by 2, so let's just do that, and that would make 56, I believe. Yep, that's also divisible by 2, circle that, that makes 28, which is again divisible by 2, that makes 14, which is 2 and 7. Cracking. So 120, that is 2 and 60. Circle the primes, that's 2 and 30, which is 2 and 15. Circle the primes, 3 and 5. Lovely. Now you can also just double check that on your calculator by typing in 336 equals shift fact, and you get 2 to the 4 because there are 1, 2, 3, 4 of those. Perfect. So that is 2 to the 4, and you get a 3 and you get a 7, which is confirmed by the calculator, so that's all good. And I'll just double check as well for the 120. So you press equals and then you press shift fact, and you get 2 to the 3 times 3 times 5, which is correct because you've got these, and you've got this, and you've got this. Okay, so the highest common factor is all of the ones that they share. So they share 3 2s, so 2 to the 3. They share a 3, and that is it. So that's 8 times 3, which is 24, and that is the answer to the first question. And we are good. Okay, question number 2. A biased 4-sided die has probabilities as shown in the table. Blah, blah, blah. 2 of them are blank. The probability of the die landing on 1 is twice as likely as landing on 4. The die is rolled 200 times. Work out an estimate for the number of times the die will land on an even number. So, if we call this one x, because it has the smallest probability out of the two, out of 1 and 4, because the probability of it landing on 1 is twice as likely, so that would be 2x. And what we know is when we add up the probabilities, they will always sum to 1. So let's just create an equation like so. This is 3x plus 43, so 0.43, equals 1. Subtract 0.43 from both sides, gives me 1 minus 0.43 is 0.57. Divide through by 3, it gives me x is equal to 0.19. So over here I can say this is 0.19. And over here 2x will be 0.38, 2 times 0.19. Okay, now we want to know the estimate for the times it will land on an even number. So let's work out that probability. It's this one, add this one. So the probability of an even will be 0.16 plus 0.19, which is equal to 0.35. Okay, so if it is rolled 200 times, the expectation, how much you would expect to get, is the probability times by the number of rolls. So it's 0.35 times by 200, which gives us 70. And that is our final answer, so I'll box it up. And that is all good. Okay, question 3 on averages. So we have 5 bits of information, and it says that there are 8 exams taking place. So we need to work out the final 3. So if we just write them all out like so, and then we can see where the final 3 must need to fit in. So, whoops, that should be 82. Okay, so those are the ones that we know. Now, the first thing to start off with is that it says that the mode of his marks is 72. So that is the most common mark. So there needs to be another 72 in there. So let's put it in here. Let's just put it in here. Okay, so now we've got that fixed. It then says that the median is 71. Now, because there's an even number of numbers, it means that the median is going to be a set of the 2 in the middle that we have to take the average of. Now, because the median is 71, and we've already got 4 numbers that are bigger than 71, it means that the median is going to be these 2 numbers averaged. So because those are the 2 that are in the middle, because there's definitely going to be 3 over here. So this one needs to be 70, and that will give the middle 2 an average of 71, and therefore the median will be 71. Okay, so we've only got one more to pick now, and it says the range, which is going to be, now the bigger one here, this 82, that's fixed. We can't have any other numbers to the right here, the bigger numbers. So it means that this range, all the way back to the start, needs to be 18. So therefore, this needs to be 64. Yes, because 64 plus 82, 64 plus 18 is equal to 82. So those are our numbers. So the ones that we've picked are 64. We had to put in a 70, and we had to put in another 72. So those are the 3 extra exams scores. Bosh. Okay, next question. It says the table below shows information about 3 fictional large lakes. Each lake's surface area and volume are given in standard form. Okay, cracking. Work out the total surface area of these 3 lakes. Give your answer in standard form. So the total surface area be if I add these 3 together. So I'll just do that on my calculator, and I'll make use of the standard form button at the bottom. So 2.5 times 10 to the 10 plus 1.2 times 10 to the 11 plus 7 times 10 to the 10. Press equals, and there's our answer. So 215 times 10 to the 11. Work out the volume of Lake Borealis. The volume of Lake Borealis is K times the volume of Lake Aurora. Work out the value of K. Okay, so K will equal the larger one, Borealis, over the smaller one, Aurora. So we have to do the volume. So it's 2.75 times 10 to the 12 over 5 times 10 to the 11. It says give your answer correct to two significant figures. So that's fine. We could do that just by doing this on our calculator. So 2.75 times 10 to the 12 over 5 times 10 to the 11. And we get 5.5. Perfect. 5.5, and that is the two significant figures, so that is good job. So that's that one, and that's that one. And we're just going to box up all the answers so it's nice and clear what the final answers are. Okay. A city uses 9.5 times 10 to the 7 meters cubed of water per day. If the city's only water supply was from Lake Celestia, work out how many days it would take for the city to completely empty the lake. Give your answer in standard form. Okay, so what we're going to need to do is we're going to need to figure out how many of these go into the lake, which has a not a surface area, it's the volume of the lake. So it's this. So it's 3 times 10 to the 12. So we're going to have to do 3 times 10 to the 12 divided by 9.5 times 10 to the 7. Okay, so it will be 3. Let's do the fraction sign first. So it's 3 times 10 to the 12 divided by 9.5 times 10 to the 7. And that gives us this. So that's equal to 31578.9. It says give your answer to in standard form to three significant figures. So that is 3.16. Those are the three significant figures. And then that is times 10 to the power of 4. Because you could tell it's times 10 to the power 4 because the decimal point moves 1, 2, 3, 4 spots to get in between the 3 and the 1 like it is here. Okay, perfect. So we can box that up, and that is job done. Okay, Gladys runs a furniture shop. She buys a table for $465 and sells it for $520. Calculate the percentage profit she makes from selling this table. Okay, so the percentage profit is the amount that she sells it for minus the original over the original and then times through by 100. So that is 520 minus 465, and then divide that by 465 and then times through by 100, and we get 11.8%, and that is to three significant figures. Perfect. Okay, Gladys has a sale in her shop and reduces all prices by 12%. So what I like to do when I see that it says reduces by 12%, I just like to write what the multiplier is, because I don't want to be tempted to kind of, times or divide by something which is not what is happening. So reduces by 12% means that it's a multiplier of 0.88 because it's 12% less of 100%. The sell price of the armchair was this. Okay, so the price before, work out the price of the armchair before the sell. So the price before was multiplied by this, and it then gave me an answer of this. So to find the before price, we need to reverse this process, which would be to divide by the multiplier. So we'll do 550, and then we'll divide that by 0.88, and we get 625. 65, perfect. So box that up. Okay, next off it says Gladys purchases a second-hand sofa for £900. There's an additional shipping fee of £75 that she must also pay. She plans to sell the sofa so that she makes at least 15% profit. Find the minimum selling price she should charge for the sofa to ensure the 15% profit. Well, if we want 15% profit, then we'll do the selling price minus the amount she paid for it, or the original, which will be 975, because she also has to use the spend this shipping fee, and then divided by the original, times that by 100, and that should equal 15. That's what we want. We want a 15% increase. So if we divide both sides by 100, we get the selling minus this over this will equal 0.15. And then if we times both sides by 975, then we get this on the right hand side. So we have the selling minus 975 will equal 146.25. So the selling price to get 15% profit, which is to add the 975 over, and we get 1,121 and 25 cents. Perfect. So put that in here, and then we'll box it up, and that will be job done for percentages. Lovely. Okay, question number 6, compound interest. Thomas invests £5,000 in the savings account for 4 years. The account pays compound interest as follows: 4% for the first year, 3% for the subsequent years. Work out the value of Thomas's investment at the end of 4 years, the nearest pound. Okay, so we're going to take the amount of money, and then for the first year, we're going to times it by 1.04. Because it's a 4% increase, so that's 4% above 100, and as a decimal that is 1.04. And then for the next years, the interest rate is 3%, so we're going to be multiplying by 1.03, and we're going to be doing that for 3 years. So I'm going to do it to the power of 3, because we want to do 4 years, but we've got the first year already done, and now we need 3 more of the subsequent years. So that's going to just go straight into my calculator. We'll do 5,000 multiplied by 1.04 multiplied by 1.03 to the power of 3 equals, and we get 5, let's write it up here actually, 5682.1804. Now it says to the nearest pound, so that is 5682. Perfect. Right, Thomas wanted to have at least £6,000 in the account at the end of the 4 years. Work out the least amount of pounds Thomas should have invested to achieve this goal. Okay, so the original investment was multiplied by 1.03, and then it was multiplied by it was multiplied by 1.04, and then 1.03 to the power of 3. And if we want that to be 6,000, then to reverse that process, we just need to divide through by those multipliers to see how much we should have started with. So just reversing the process, so we'll do 6,000 over 1.04 multiplied by 1.03 to the power of 3, and we get this. So that is 5279.66. So 5279.66 is the final answer for that one. Perfect. Okay, expanding brackets. So what I'd like to do here, I think, would just be to expand out the double brackets first, and then we'll multiply through by 2x afterwards. So expanding this out is going to give us, that'll be 12x. This will be minus 6x squared. This will be minus 4, and this will be plus 2x. But then let's not forget that we still need to multiply through by 2x. Okay, first what I'll do is I will just collect up the x's inside the bracket, of which there are 14, because it's a 12 and a 2. Minus 6x squared minus 4. And then we're going to multiply through by 2x. So it's going to give us 28x squared minus 12x cubed, and then minus 8x. And that is job done. And then we are on to the next. Okay, indices. So it says you are given that, this lovely formula here. Find an expression for n in terms of x and y, showing you're working clearly. Well, the first indice rule we can see here is that when you have a power and then raised to another power, then we can just multiply those two powers together. So it becomes 3 to the 1/2 n. And the next thing to spot is the fact that these numbers here are all powers of 3. So we can write 9 as 3 squared, and then we can write 27 as 3 cubed, like so. We can then write this as 3 to the 2x over 3 to the 3x, because again we can just multiply. If you've got powers stacked like that, we can just multiply the powers. And then when we have, in this case, 3's, one divided by the other, then what happens to their powers? Well, we subtract their powers when we divide through, in this case, 3's. So we get 3 to the 2x minus 3y. And now we've got both sides of the equation as just 3 to the power of something. Then these two somethings must be the same. So 1/2 n must equal 2x minus 3y. And then timesing both sides by 2 gives us 4x minus 6y. And that is our final answer. Bosh. Okay, Pythagoras. It says the diagram shows an isosceles trapezium. Given that BC is equal to 2AB, so this bottom here is equal to, is twice the size of this parallel line at the top here. H is 5 and the area is equal to 60. Find the perimeter of ABCD. Okay, lovely question I've created here. How are we going to solve it? Well, the area of a trapezium is a half A plus B times by the height. And we know that this is equal to 60. So what are A plus B? Well, they're the two parallel sides. So let's call this side x, and that means we can call this side 2x because the bottom is twice as big as the top. So this will be a half x plus 2x times by h, which is 5, and that's equal to 60. So we have 1/2 3x times 5 equals 60. And then if we, what's the best way of doing this? Let's times both sides by 2 to get rid of this half. So it becomes 3x times 5 is equal to 120. And then we can divide both sides by 5. And that gives us 24. So x is equal to 8. Cracking. Okay, so this is equal to 8 and this is equal to 16. Now, we're asked to find the perimeter. So what do we know? Well, we know we know this and we know this. We don't know these two sides over here, this side and of course this side. Now the key part here is that it is an isosceles trapezium, which means that these two are the same distance. And what it means is that we could draw a line down here and split this shape up perfectly by the symmetry. So we can have these two triangles on the side, and this is where the Pythagoras part comes in. Okay, so we know this height is 5, and given that this across here is 8, so this must be across here is 8. So therefore, these two must also add up to 8, so the whole thing adds up to 16. So that must be 4, and that must be 4. And if that way, this is 8, then you've got 4, 8, 4, which adds up to 16, which is perfect. So let's find this distance here. Let's call it d. So d is going to equal the square root of, by Pythagoras' theorem, 4 squared plus 5 squared. So we can put that onto our calculator. So square root of 4 squared plus 5 squared will equal root 41. Let's write it out as a decimal, I think, probably. So 6.40. Okay, so the overall perimeter is going to be 8 plus 16 on the bottom, those are the two yellow, plus 2 times 6.40. So on my calculator, I'll just times that by 2, and then I'll add on, I can press equals, then plus on 8 and plus on 16. Okay, so that's my final answer. So I'll give that to 3 significant figures like I've been asked. Perfect. Okay, there we go. That is centimetres, and that is job done. Okay, we've got trigonometry, and it says the diagram shows a triangle ABC. In the triangle, AB is equal to BC. So this is an isosceles triangle, which means we can draw a line of symmetry right down here, and we'll get a right angle just like that. It says AC is 11, so that means that this side we can call 5.5, and obviously this side 5.5, because that line down the middle splits it down the middle. So half and half either side. It says find the area of the triangle. Okay, so for the area, I'm going to need the perpendicular height, which is going to be this distance here. So I can use trigonometry for that, because I have an angle here, and I have the opposite I'm looking for, and that is next to the angle, so that's the adjacent. So we use tan when we have opposite and adjacent. So we say tan of the angle is equal to the opposite over the adjacent. So tan of 43 is equal to h over 5.5. So h is equal to 5.5 times tan of 43. Okay, so we could do that on our calculator. We could do 5.5 multiplied by tan of 43. Check you're in degree mode, which we are. Perfect. So that is equal to 5.13, let's say. So the area is equal to a half times the base times by the height, which is a half times by 11 is the base, and the height is what we've just worked out. So I'll just take that height times by 11 and times by a half. Perfect. So we get an area of 28.2. Yes, 28.2. That does the job. Okay, perfect. Okay, I've got area and perimeter. This says the diagram shows two circles inside a rectangle. Work out the area of the shaded region. Okay, so first off, let's work out the area of the overall rectangle, which is just base times by height, or length times by width, which is 11.5 multiplied by 7.8. So we can do that, no problem. So that is 11.5 times by 7.8, which gives us 89.7. And then we need to work out the area of the circles. So let's go for circle 1. Let's call that the large circle. It'll be pi times by r squared, which will be pi times by 3.5 squared. Okay, so that will be pi times by 3.5 squared, and we'll get 38.48, and then we'll do circle 2, which will be pi times r squared again, but this will be just pi times by 1 squared, which is just pi, which is just 3.14, as we know. So I'll take this number and I'll just add on the pi, and that gives us the two circles. So the shaded region is just going to be the 89.7 minus the 38.48. In fact, it's just minus this, isn't it? Yeah, because we've just added the two together, so we're just taking that away. So it's 89.7 minus that previous answer, and we get 48.1. And that is good. That will be centimetres squared. And that is a wrap. Okay, so the table gives information about the average speed of 200 go-kart drivers. Complete the frequency, the cumulative frequency table. Fine. So we've got 6 are going that fast. So that is just 6. And then we've got plus 48. So add on 48 gives us 54. Add on 54 gives us 112. Add on 36 gives us 148. Add on 30, 178. And then add on 22 is 200. Perfect. It adds up to the total, so we feel pretty confident that we've got that one right. And now it says draw on the grid the cumulative frequency graph. Okay, so just zoom out a little bit, and we'll start with 6. Be very careful where to plot. You have to plot the endpoints. So I'm plotting 6 at 50, and I'm being very careful as well because that's 20 there. So it means it goes up in 4s. So 4, 8, 12, 16. So 4, 8. So it's halfway between 4 and 8. So it's there. 60 is 54. So 40, 44, 48, 52, 56. So it's halfway between 52 and 56. 112 for 70. So that's 100, 4, 8, 12. 80 is 148. So that's 140, 4 and 8. 90 is 178. So that is just shy of 180. It's half a square shy of 180. 180. Let's go. And 100 is 200. Cracking. Okay. So on the grid, draw the frequency diagram. So what I will always do now is just connect them up with straight lines. Just like this. Just like this. Just like this. Just like that. And then just like that. Perfect. Job done. Okay. Use the cumulative frequency diagram to find an estimate for the median. So the median occurs at the 100th position because there's 200 in total. So we'll go across to there, and then we'll come down to here, and that is 68. And of course we can be a little bit lenient if we have not drawn our graph exactly the same as I have, but we will go for 68 as our answer there. Okay, it says to qualify for the Mr. Asprey Speedway, riders need to average at least 87 kilometers per hour. Use your graph to estimate the percentage of drivers who qualified. Okay, so we're going to go up here, back to our graph, and we're going to go to 87. We're going to go up, and we're going to get to roughly about here. So it looks like halfway in between these two squares here. So that's 160, 164, 168, 170. Yeah, it's perfectly 170, I believe. Again, a little bit of leniency allowed. So that means that the top 30 people qualified for the Speedway. So we've got 30 people out of 200 times by 100, as we want it to be a percentage. So that is 15%. Perfect. 15% is our answer. Again, a little bit of leeway allowed. If you got slightly off, that's fine. Okay, question number 13, we're on sketching graphs, and we are going to use our table function for this. So we're going to go into table function, like so, and we are going to then go for x squared minus 2 over x. We're going to press equals. We don't need a second function. We need to start at 0.5, end at 5, but we're going to want to go up in steps of 0.5 to make sure we hit all of the numbers that we need. Okay, great. So it does ask to give us our answers to one decimal place. So the first one is going to be minus 3.8. That one's given already. This one is going to be 0.292. That's going to be 3. We don't need 2.5. This is going to be 8.3. And then this one's going to be 15.5. And then the next one is going to be 24.6. Okay, so I made this a bit trickier. We need to use our good eyesight here and be confident with the scaling. So first off, that's 1. So every 2 small boxes is going to give us 1 value. So every small box is half. So it's always good to just make sure we know that to start us off. So if we want minus 3.8, we're going to go minus 2.5, minus 3, minus 3.5, minus 4, so it's kind of halfway in between those two there. 1 is at minus 1, which is there. 1.5 is at 0.92, which is just below 1. 2 is at 3. 3 is at 8.3, so we've got 7.5, 8, 8.5, so it's kind of halfway between those two. 4 is at 15.5, so we've got 15, then 15.5, and then 5 is at 24.6, which is pretty much 24.5, which is right there. Okay, next what I'm going to do is I'm going to join them up. Now it needs to be in a bit of a curve, so it's going to get a bit steeper like this, like that. Okay, so that should do the job. Next, let's go down here. Right, one of these questions where it says, by drawing a suitable straight line on the grid, find an estimate to one decimal place of the solution to the equation. So, for these types of questions, we're going to want to write what we have already on the graph, just on the left-hand side over here. So it's x squared minus 2 over x. Now the goal is to get the left-hand side of this equation. We want to manipulate it so that it gives us the green equation, which we've got drawn on the graph already. Okay, so let's manipulate this equation. So the first thing I can see is we've got an x squared over 2, and here we've just got an x squared. So multiplying by 2 is going to give us x squared minus 2x is equal to 2 over x. And now I want, again, the left-hand side to be what we've got over here. So we're going to take the x squared, leave it there, but we're going to move this one over. So we're going to subtract it from both sides. And then we're going to move this guy over to there. So we're going to add 2x to both sides. So it's going to look like this. And now we've got our green equation, all good on that side. And then over here on the right, we've got 2x. So we're going to need to draw y is equal to 2x because we've already got y is equal to x squared minus 2 over x drawn. So when we draw both of them on the graph, where they intersect will be the solution to this equation, which is the same as the equation we're trying to find the solution to. Okay, so we need to draw y equals 2x. So we know it goes through 0, 0 because there's no intercept. And when x is 5, y will be 2 times that, so it'll be 10. And that's all you need. You need just 2 points and you've got yourself a straight line. Okay, lovely. So I just realised maybe my graph's slightly off here. Let me just draw it a bit more like so. I think that's better. Okay. So we can see here that they meet at 2.5. So perfect. That is going to be my answer. So the answer to the question I'm going for here is 2.5 to 1 decimal place. And in fact, what we could do is we could check our calculator to see if in fact when x is 2.5 the value for y is to 1 decimal place 5.5, which seems to me pretty much exactly kind of what we expected it would be right here, like this. So that looks good to me, and it seems to me like that is good. Okay, probability. We've got Emma and Noah play a tennis match. The probability that Emma wins the first set is 0.6. And then it says that if Emma wins a set, the probability she win the next is 0.7. And if Noah wins a set, the probability he wins the next will be 0.4. Okay. So first set, Emma wins 0.4, which means, 0.6, which means Noah wins, has a chance of 0.4. So if Emma wins, after every Emma wins, we get 0.7 for the next one, which means Noah will be 0.3. Okay, so now, after Noah wins, the chance that he wins the next match will be 0.4, as it says here. So Emma's will be 0.6. Again, if Noah wins, the chance of winning the next one is 0.4. And that means Emma will be 0.6. But if Emma does win, then the chance of her winning the next one is 0.7, which means Noah will be 0.3. So that is the tree diagram completed. So it says the first player to win 2 sets in total wins the match. Okay. Calculate the probability that Emma wins the match. Well, we can just look at the branches which are going to give her 2 wins. So this one, that gives her 2 wins. Or win, loss, win. That does it. Or loss, win, win. So these are the branches which give her success. So we just multiply them through. So the first one is 0.6 times 0.7. Or we could have 0.6 times 0.3 times 0.6. Or we could have 0.4 times 0.6 times 0.7. Okay, great. So we can work out each of these. So I will do them individually just to let the examiner know what I'm doing. So that is 0.42 plus the next one is this one here, which is 0.108, and then the last one is this times by this times by this, and that is 0.168. So we'll add that up like so, and we get an overall answer of 0.696. Okay, great. Alright, so if Emma loses the first set, what is the probability that she loses the match? Okay, so let's get rid of these things here. And it says that, again, if she loses the first set. So she has lost the first set for all intents and purposes. So we're only looking at this part of the tree diagram because she's lost the first set. What's the probability she loses the match? Well, let's look at the branches which are going to give her a loss. So there's a 0.4 chance that she loses just in the next set. So 0.4. Or she could stage a little bit of a fight back, but then lose the final set. So that's the other way which she could lose. So plus 0.6 times 0.3. So this is the total probability. Because remember, this is why this question is a bit tricky, because it says that if she loses the first set, so that's happened. So we're only looking now at what's going to happen in sets 2 and 3, and the chance that she loses one more set from sets 2 and 3 are given as this. So that is our final answer. Okay, we've got bounds. It says this is blah 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 rounded to certain levels. Work out the upper bound of the value of t. So normally they give you t as a subject, but I made this slightly trickier in that you've just got to rearrange for t. So we're going to do v minus u is equal to at, and then we're going to divide through by a, and we're going to get t as the subject. So t is equal to v minus u over a. Now if we want t upper, then we're going to want to make the numerator as big as possible. So I'm going to want v upper, and if I am subtracting u, I want that to be as small as possible, because I want to make the overall numerator as big as possible. So I want to take away as little as I can. And then when we're dividing the denominator, we want that to be small, because the smaller the denominator, the bigger the number. Okay, so let's look at v. V is 26.7 to 1 decimal place. So if I want to go below by 1 decimal place, I would go to there. If I want to go above, I would go to there. Now because we're looking at the upper bound, it's halfway between the value and the next one along. So it is 26.75. So 26.75. And then if looking at u, that is 14.78. Corrected 2 decimal places. So if I'm only using 2 decimal places, the number below it would be this, and the number above it would be this. We are looking for the lower bound, so we go halfway between these two, and that gives us a value of 14.775. So that's the lower bound there. And then that's all over the acceleration, and the acceleration is 4.0 to 2 significant places. So that will be 4.0. If I'm only using 2 significant figures, it will be 3.9 and 4.1. We want the lower bound, so that is there, and that is 3.95. So that is over 3.95. Okay, great. So that just goes into our calculator. 26.75 minus 14.775 over 3.95, and that gives us 3.03 to 3 significant figures. That is job done. Okay, next we've got circle theorems. And we've got that these all lie on the circle. The line PTU is a tangent, and the line PQR is a straight line. Find the angle T, so T to P to Q must be this angle in here. That's what we're looking for. This is a straight line, so we know this angle here is a 180 minus 99. Which is equal to 81. So that's 81, and we can write here angles on straight line add to 180, because it does say give a reason for every step of your working. Okay, the next thing we could do is, yeah, let's work out, there's two ways of doing this actually. Let's work out this way. Let's use as many circle theorems as we can. So this will be 99 because opposite angles in a cyclic quadrilateral add up to 180. So 99 plus 81 is 180. So we can do 180 minus 81 equals 99, and that is because opposite angles in cyclic quadrilateral add to 180. Okay, great. And now we can say that we've got a triangle here which has three corners on the circle and one corner at a tangent. And that means we can use the alternate segment theorem. So this angle in here is the same as this angle that it hits the tangent to. That's by the alternate segment theorem. And also, by the same theorem, this one here is the same as this one here, but we don't really need that one right now. So if that orange angle is 99, then I can say that PTR equals 99 by alternate segment theorem. Okay, so therefore this angle in here is clearly 99 minus 39. So we can say that angle PTQ is equal to 99 minus 39. We don't need a reason for that. That's just because, well, they just add up to the same thing. And then finally, if that makes that 60, of course. Yes, it does. So that's 60. So therefore we can say that TPQ, the one we're actually looking for, is going to be 180 minus 99 minus 60, which is equal to 21, and that is because angles in a triangle add to 180. Perfect. Okay, we've got number 42, quadratic simultaneous equations. We've got a line, so this is the linear one, and then we've got the curve, which is the quadratic one, and they intersect at A and B. So to find the intersection points, we have to solve the quadratic equation, also the simultaneous quadratic equation. So what we're going to do is take the linear one and we're going to make x or y the subject, and we're going to pick x because it's just nice and easy to do that. We just add x to both sides and then we minus 1 from both sides. That makes x the subject. If we pick y, then we have to be divided by 2. We're going to get halves. I don't really want that. I think this is just the nice and easiest way. Then we just write out the green one again, but we just, every time we come to an x, we replace it with 2x minus 1. So we write 3y squared plus, not x, but 2y minus 1 is equal to x squared, or 2y minus 1 squared, minus 14 minus 5y. Okay, so this bracket isn't necessary. This one needs to be expanded. To do that, we would write it out like this. So we're going to get 4y squared. We're going to get a minus 2y and another minus 2y, so minus 4y. And then we're going to get 1 times 1, also minus 1 times minus 1 is 1. Minus 14 minus 5y. Okay. Let's just do as much simplifying as we can. So this is 4y squared minus 4y and minus 5y is minus 9y, and 1 minus 14 is minus 13. Then let's bring everything over to the right side because it has more y squareds, and that means I'm going to keep my y squared positive. So moving that over, we'll take away 3y squared from both sides, so just leave me with y squared. Moving this one over, we'll take away 2y from both sides, so that just gives me minus 11y. And then moving the minus 1 over, we'll add 1 to both sides, which gives me minus 12. So this can factorise. We want two numbers that times to make minus 12 and add to make minus 11. So that would be minus 12 and plus 1. So this means that to make this bracket 0, y must equal 12. And to make this bracket 0, y must equal minus 1. And now we need to go back and find a corresponding x coordinate. So the x coordinate is the y coordinate doubled, so 2 times y, then minus 1. So times this by 2 is 24, minus 1 is 23. Times this by 2 is minus 2, then minus 1 is minus 3. Okay, great. But we're not quite done yet because the question says find the gradient of the line AB, the line segment AB. So these are the two coordinates, like so, and the gradient, we need to do a calculation. So the gradient, m, is y2 minus y1 over x2 minus x1. So if we call this one x1, this one y1, and this one x2, and this one y2, then we just need to sub in, and we're good. So it'll be minus 1 minus 12 over minus 3 minus 23, which is minus 13 over minus 26, which is 1/2. And that is a beautiful question that I designed. Yay! Okay, question 18. It says the power density, P, in watts per meters squared of microwaves emitted by an antenna is inversely proportional to the square of the distance, d, in meters from the antenna. When d is 5, the power density is 36. Express P in terms of d. Okay, so it's inverse proportional, so we can say that P is proportional to 1 over the square of the distance. So we can say P is equal to a constant times by 1 over d squared, or k over d squared. So when P is 36, d is 5, so we can sub that in. So therefore we can solve for k by just doing 36 times by 5 squared. So we can do that on our calculator. So we will do 36 times by 5 squared, which is 25, to get 900. Lovely. So the formula is P is equal to 900 over d squared. Okay, it says find the value of d when P is equal to 16. Fine, so 16 is P, and that's equal to 900 over d squared. Multiply both sides by d squared, gives us this, and then divide both sides by 16, gives us this. So d will equal the square root of 900 over 16. Okay, cracking. So square root of 900 over 16, and that gives us 7.5. Perfect. That's answer for part A, that's answer for part B. Lovely. Okay, it says the histogram shows the daily screen time of all the Year 11 students at Asbury Academy. 42 students had a daily screen time between 2.5 and 3.5. So what I'm going to do is I'm just going to draw a line down there at 2.5 and draw a line down there at 3.5. And we know that all this area is equal to 42. So, how are we going to do that? We could count boxes, or we could label the frequency density x. So I'm going to do that because sometimes it's not always easy to count boxes. So if I just go up here and label it 1x, 2x, 3x, 4x, 5x, 6x, 7x, and 8x, then we can look at the area of this purple section. So this first bit is a half across times by 3x, the height. Add the second part, which is also a half across, times by 7.5x. And the area of a histogram is always equal to the frequency that it represents, at least at GCSE it is, and that's equal to 42. Okay, great. So how many x's do we have there? So we've got 0.5 times by 3 plus 0.5 times by 7.5. And that gives us 5.25x is equal to 42. So we can work out what x is equal to by doing 42 over 5.25, which is 8. Perfect. Okay. So from this, we can actually work out now how many people there are in total, which I think we're going to need to know anyway, because it says the probability. So we're going to need to know what the whole thing is out of. Okay. So let's get rid of this, and then let's just work out the area of each of these 3 blocks. So this one is 3x times by 1, it's 1 across. X is 8, so 3 times 8 times 1 is 24. This one is 1 across, and it's times by 7.5x, and then times by 1. So 7.5 times 8 is 60? Yes. And then this final one here is a height of 4.5, so 4.5 times 8, and then times by again by 1, so 36. Okay, so that's the total number of people. So 36 plus 60 plus 24 gives us a total of 120. Okay, great. And now it says find the probability that both of these people that were selected have a screen time higher than 4 and a quarter, so 4.25. So I would have to draw a line in here at 4 and a quarter, and it says greater than, so I want all of the people this side. So assuming the bar is equally split, which we do, it means that this quarter of 39 is a quarter of 36 is 9, and then 3/4 on the other side is 27, like so. Perfect. So now if 2 people are selected, the first person selected has a chance of 27 out of 120. The next person selected, there's only 26 people remaining, and then that's out of 119 in total. So that's the calculation that we have to do. So 27 over 120 multiplied by 26 over 119. And that gives us this fraction, or if you wrote it as a decimal, 0.049. Perfect. Okay, solve, showing clear algebraic working. So the first thing to spot I think, is that we can make these denominators all the same relatively easily. So if we factorise the first one, then it is x minus 1. And then if we write the next one, like so, we can make the denominator the same by multiplying top and bottom by x minus 1. And on the other side, we have x minus 1, and we've got 3x minus 1 on top. And again, we can make the denominator exactly the same by multiplying through by x, top and bottom. So now, the denominators are all the same, which is great, because essentially it means they can just all cancel out. We can multiply the whole equation by x minus 1, and that will indeed cancel each of these out. So our overall equation now becomes 2x squared plus x minus 1 plus this bit here, which is 2x minus 2, is equal to this bit here, which is 3x squared minus x. Okay, we'll just tidy this up. So plus 3x and then minus 3 on that side. We'll then subtract 2x squared. So we get 1x squared over there. Bring it all over to this side. We'll get x squared minus 4x when we take away the 3x from the minus 1x. And then add 3 when we add this minus 3 over to the other side. Or add 3 to both sides. This can be factorised. Two numbers that times to make 3 but add to make minus 4 are minus 1 and minus 3. So our solutions are x equals 1 or x equals 3. And that is job done. Bosh. Okay, we've got a function and it says express it in the completed square form. Okay, so we'll say f of x is equal to, the first thing we need to do is isolate the x squared. So we need to take out a factor of 2. So we get x squared minus 2x. Now some people will divide that by 2 and put it inside the bracket. Personally, I just close off the bracket and then leave it outside. So now we've got to complete the square on x squared minus 2x. So to do that, I'm just going to write x minus 1, because it's half of this value, squared, and then minus, again, that same number, half of the yellow value, squared. So that's how we complete the square. And that will be, yeah, so 2x minus 1 all squared, and that will just be minus 1, because minus 1 squared is 1, but then we're taking it away, so it is minus 1. And now multiplying the 2 over here and into here gives us 2 lots of x minus 1 squared, minus 2, and then minus 13. So overall, my final answer is 2 lots of x minus 1 squared minus 15. Okay, perfect. It then says describe geometrically 2 transformations which map the graph of x squared to the graph of f of x. Okay, so we have x squared and we want to convert that to 2 lots of x minus 1 squared minus 15. So let's imagine if x squared was, let's just call it g of x. Then what has happened to x squared? Well, the x has turned into an x minus 1. Because x has been squared, and over here x minus 1 has been squared. So it is actually g of x minus 1. And then after that's happened, we've multiplied by 2. So it's actually timesing the whole thing by 2. And then we're going to minus 15, like so. Okay. So how does this represent in graph transformations? Okay, so the 2 multiplied by the g of x is going to stretch in the y-axis. So it's going to be a stretch in the y-axis of scale factor 2. And then inside the bracket we've got -1. Now that is a translation 1 to the right. And then outside the bracket we've got -15. That's a translation down by 15. So overall we're going to translate by the vector. It'll be 1 to the right and it'll be down 15. So it'll be the vector 1 minus 15. Okay, 49 Surds, question 22, and this is an absolute beauty. I was very happy when I created this one. So we're going to start just by writing out the left-hand side. So 49 over, we're going to write 3 plus root 2 times by 3 plus root 2, because it's a squared bracket like that. Okay, so this is going to be 11 minus 49 over, so we're going to get 3 times 3 is 9, plus 3 times root 2 is 3 root 2, plus root 2 times 3 is 3 root 2, and then root 2 times root 2 is 2. So I want to make sure I'm showing clear working here. So that's 11 minus 49 over, so 2 plus 9 is 11, and then we've got 6 lots of root 2, because we've got 2 free lots of root 2. And then we're always going to want to rationalise a denominator when we can see one. So let's times this top and bottom by 11 minus 6 root 2, like so. Okay, so that's 11 minus, and then we'll do, on our calculator, 49 times 11 is 539, minus, because there's minus here, 6 times 49, so that's minus 294 root 2, all over 11 times 11 is 121, and then there's going to be minus 66 root 2 plus 66 root 2, and then 6 times minus 6 is minus 32, sorry, minus 36. Root 2 times root 2 is 2, so minus 36 times 2 is minus 72. Okay, right, let's clear this out. So the denominator becomes 121 minus 72, which is 49. Okay, great. So we've got this over 49. Now here, we're going to hope that these numbers on top can be divided by 49, which they can. So we get 11. So we get 11 minus, I'll put it in brackets here, 11, and then this needs to be divided by 49 to get 6, so minus 6 root 2. Like, okay, so carrying on, we've got 11 minus 11 is just 0, and then we've got minus 6 root 2 is just 6 root 2. Now we want to write that, as the question says, as root k. So we need to write 6 as root 36, because that's the same as 6 times then root 2, and that is going to give us root 36 times 2, which is 72. So the final answer is that k is equal to 72. Perfect. Okay, very happy when I made this question. The cone has total surface area of 200 pi. The cone is melted down to create 16 identical spheres. Find the radius of the spheres. Give your answer to 3 significant figures. Okay, so the total surface area, well, the curved surface area, is equal to pi RL. and the base is obviously a circle, so that's pi r squared. So the total surface area is pi rl plus pi r squared. And we know that's equal to 200 pi. So 200 pi is equal to pi r, and then L is the slanted height, which is what we're given, so 17, plus pi r squared. We can divide through by pi. We'll get 17r plus r squared, like so. And then we can bring it all over to one side to get r squared plus 17r minus 200 equals 0. This can factorise, so two numbers that times to make minus 200 and add to make 17 are plus 25 and minus 8. So r is equal to either minus 25, because that's the value of r that makes this bracket 0, or r is equal to 8. So clearly r must equal 8 because it's a radius and it can't be negative. So we know that this in here is 8. Now that allows us to work out the height, because we've got a right angled triangle here. So we use Pythagoras. So we can say the height is equal to the long hypotenuse squared minus the other short side squared. So we can do that on our calculator. So square root of 17 squared minus 8 squared. And it comes out as a nice whole number. How lovely. So now this allows us to work out the volume of this cone. And the volume of a cone is a third pi r squared h. So it's a third times by pi times by, the radius is 8 and the height is 15. Okay, lovely. So we get 1/3 multiplied by pi, which I'll just leave out for now. 8 squared times by 15. So it gives 320. So the volume is 320 pi. Okay, it says that we are creating 18 identical spheres. So the volume of a sphere will be 320 pi over 16. And 320 divided by 16 is 20. Okay, perfect. So the volume of a sphere is, that should be 20 pi, sorry, is 20 pi. And the volume of a sphere is 4/3 pi r cubed, as we know from our formula sheet. We can divide through by pi, and then we can divide by 4/3, like so, and we get 15. So we get 15 is equal to r cubed. So r is equal to the cube root of 15, which is equal to, three significant figures, 2.47 centimetres. Oh, what a beautiful question, eh? That was a good one, right? Yes. Okay, ABC is a triangle. Find the area of the triangle ABC. Give your answer correct to three significant figures. So you can tell I made these questions because there's the occasional spelling mistake. Okay, I'll correct that though. Correct it. Okay, so we've got a triangle and we need to find the area. So to find the area, we would, first off, we've got to find x. We've got three sides and an angle, so we're going to use the cosine rule. So the cosine rule tells us that a squared is equal to b squared plus c squared minus 2bc cosine of capital A. We shouldn't really look at these, but in fact they are actually in the perfect position because we've got the angle as capital A. So this side is little a, which means these two are b and c. Well, if that's capital B, then this one will be little b, and that will be little c, but it doesn't actually matter. Anyhow, x plus 9 squared is a. B will be 2x squared, plus c will be 3x plus 1 squared, minus 2 lots of b times by c times by cosine of a, which is 60. Okay, great. So we've got a lot of expanding out to do here. This is going to be x squared plus... we've got a lot to do here, so I'm just going to expand it out quickly. So it's going to be 9x plus another 9x, so 18x, and then 9 times 9 is 81. This is going to be 4x squared. Don't forget to square the coefficient here as well. Here we're going to get 3x times 3x, which is 9x squared. We're going to get a 3x times a 1, which is a 3x, and we're going to get 1 times a 3x, which is another 3x, so 6x, and then 1 times 1 is 1. And we're going to get minus... Now, I'm going to take a cheeky little shortcut here, because I know that cos of 60 is a half. So that half is going to cancel with this 2. So in fact we just need to expand out these two, which is going to give us 6x squared and plus 2x. So not forgetting that both of these two terms need to be negative because we're taking away the whole thing. Okay, let's try and simplify as much as we can now. So we'll keep that as this. Over here we've got 13x squared, because 4 plus 9, and then minus 6, so that's 7x squared. Here we've got 6x minus 2x, so that's plus 4x, and then we've got plus 1 as well. Let's make this side 0, so minusing x squared gives us 6x squared, minusing 18x gives us minus 14x, and minusing 81 gives us minus 80. I can divide this all through by 2, so I'll do that just to simplify numbers down. And now we need to factorise this quadratic. So the a term is 3 and the c term is minus 40. So AC is equal to these two times together, which is minus 120. And b is equal to minus 7. So I'm looking for two numbers that times together to make minus 120 and add to make minus 7. So those numbers are 15 and 8. So minus 15 and plus 8. So I'd write 3x squared minus 15x plus 8x minus 40. So doing it in a different way than I normally do actually. I don't know why I just started doing it like this, but whatever. So 3x, x minus, I can take out a 3x from these two, so that gives me this. And then I can take out an 8 from these two, which gives me this. So overall, we have how many x minus 5s? We have 3x there, and we've got plus 8 there. So x is equal to 5, or x is equal to minus 8 over 3. Because x is a distance, it must be 5. So now we are good, because we can just sub in x as 5, which gives us 16, which gives us 14, which gives us 10. And to find the area, we just do 1/2 times a times b times sine of c. Because the angle is the one we have is 60, we're going to use sine of 60, which means now the angle is capital C. But when you do the area of a triangle, just think of, you need an angle, and then you just need the two sides which are next to that angle. So whatever the angle is, forget about the lettering. In this case it's 60, so the two sides next to it are 16 and 10. So those are the ones that we're going to use. So it's a half times 16 times 10 times sine of 60. So we'll just put that into our calculator. A half times 16 times 10 times sine of 60. And we're going to get 69.3. So 69.3 centimeters squared is our final answer. Yes. Okay, yes. I love this question. Very happy making this one. So the diagram shows a square-based pyramid. The vertex V is vertically above the midpoint M of the base. VM is equal to 3 lots of AB. The angle VAM takes, that's meant to say makes, the angle VAM, oh no, it's not meant to say makes, it's meant to say takes. The angle VAM takes the value of Y, yes it does, yes. That angle there is Y. Find the exact value of tan Y. Give your answer as root A, where A is an integer. Okay, so the reason why I did this question is because lots of these questions are coming up where they don't give you any side lengths at all. And what you need to do is you could either label like one of them X, or you could just assign one of them 1 or 2 or 3 or whatever. Now I'm going to assign this one 1, which means that VM is 3 times AB, so VM is 3. Now, I mean, you could assign it 10, or you could assign it 100, or you could assign it 2. It doesn't matter, because whatever's going to happen, all of the angles are all about the proportion, and the proportion stays the same. Okay, so if that's 1, this is 1, because it is a square-based pyramid. So now what we can do is we can look at that square base. If we have 1 and 1, then this distance across, which will be AC, is the square root of 1 squared plus 1 squared. It's a hypotenuse. So it's root 2. Which means A to M is just A to the middle. So that's going to be root 2 over 2. It's going to be half of it. Okay, great. So now we can look at this triangle, which is the triangle we're interested in because it's the one that has the angle Y. So you go to there, and then you go to here, and then you go to there. So drawing that triangle out, like so, we have root 2 over 2. We've got 3 as the height, and then Y is in here. Okay, so what are we actually asked to find? We're asked to find tan Y. So tan of Y is equal to the opposite, which is 3, over the adjacent, which is root 2 over 2. We can then times top and bottom by 2. So that will then give us, because it's a fraction, we can just times top and bottom. It's not going to affect the fraction. It's just going to rewrite it in equivalent form. So 3 times 2 is 6. And then we've got root 2 over 2 times 2 is just root 2, because the over 2 and the times 2 cancel out. We want this as root A. So the first thing we're going to do is we're going to rationalise this denominator. So we're going to times it top and bottom by root 2, which gives us 6 root 2 on top, and then root 2 times root 2 is just 2. So 6 divided by 2 is 3, so this is 3 root 2. And if we want to write this as a surd of just A, then we're going to change 3 to root 9. And then we're going to multiply these two numbers together to get 18. So the answer is root 18. Perfect. Okay, so it says we've got 3 points. It says the straight line L1 passes through BC. Okay, so let's take B and let's take C, and then let's find the gradient first. So the gradient is the change in the y, so we'll do this 5 here minus this 2, over this 5 minus this minus 7. So 5 minus minus 7. So this gives us 3 over 12, which is 1/4. Okay, great. So that will allow us then to work out the equation of the straight line, because we could do y is equal to 1/4 x plus c. We can sub in one of the points. Let's choose 5, 5. So 5 for y times by 5 for x plus c. So this is 5 is equal to 1.25 plus c. So c will equal 3.75. So we get y is equal to 1/4 x plus 3.75. Okay, great. Now we can work through about a line 2. So the gradient of line 2, because it's perpendicular to line 1, the gradient will be the negative reciprocal. So we flip the gradient of the original one over to make 4 over 1, and we make it negative, or we change its sign. So that becomes minus 4. Okay, so now we can do the equation of that straight line as well, because we know it goes through A. And A is the point 2, 0. So 0 for y, 2 for x, gives us 0 equals minus 8 plus c, which means that c must equal 8. So it must be y is equal to minus 4x plus 8. Okay, great. And then it says, find the area of the triangle bounded by the lines y1, y2, L1, L2, and the y-axis. Okay, so a bit tricky to know what to do here, so it's a good idea to just draw a quick sketch. So if I have a coordinate axis sketch like this, so let's start off with the blue line. So the blue line we know has a y-intercept of 3.75, so let's say that's there. And it has a gradient of 1/4, so that's quite a shallow gradient. So let's imagine it looks something like this. Okay, now the red line has a gradient, has an intercept of 8, so it's above the blue intercept. It's got a negative gradient, so that means it's going to be coming downwards like this. Okay, so the area that we're looking for is the triangle bounded by the two lines and the y-axis. So the area must be this, this yellow area here. Okay, so it's going to be very useful to know this point, the point where the two lines intersect. And we can find that by setting them equal to each other, like so. And then solving for x. So if I add 4x to both sides, this will give me 4 1/4, so 4.25x, plus 3.75 is equal to 8. 4.25x is equal to, so minus 3.75 gives us 4.25. Okay, brilliant. So x is equal to 1. So right there, that is 1. Now, we don't actually need to find the y-coordinate. We're actually good here. Because we've got a triangle, which if I just rotate it around, would look a bit like this. If I just was to spin it around like that. So it has a height. This height here is 1, because it goes from 0 to 1. So it's got a height of 1. Now the base of the triangle is the gap between the two y-intercepts. And the gap between the two y-intercepts is 4.25. So that's 4.25. So the area of the triangle that we're looking for is just going to be a half times by base times by height. So that will just simply be 0.5 multiplied by 4.25 times by 1. So 17 over 8. Or 2.125. Perfect. Okay, 56 functions. The functions f and g are defined below. State which value of the x cannot be included in the domain of f of x. Okay, so f of x looks like this. We can't have a denominator equal to 0, so therefore x cannot equal 2. Perfect. Okay, so it says find f of g of 12. So the first one we're going to find is g of 12. So we're going to put 12 into g, and then we're going to put that answer into f. So 12 of g of 12 is 4 times 12 minus 3 over 12. So that's 36 minus 3 over 12, which is 33 over 12, which is the same as 11 over 4. Okay, so to find f of g of 12, this now becomes just finding f of 11 over 4, because g of 12 is 11 over 4. So this is 1 over 11 over 4 minus 2. And we can put this just straight into our calculator rather than getting too overly fancy. So that is 11 over 4, and then we want to minus 2, and that gives us 4 over 3, which is good. Okay, next it says solve f of x equals 4. Okay, so f of x means that we put f of x into f of x. So I'm going to write out f of x, but every time when I get to the x, I need to replace that with itself, f of x. So it becomes 1 over, and instead of x, the new input is f of x itself, so 1 over x minus 2 minus 2. And we're told that needs to equal 4. Okay, so we've just replaced the x with f of x, so this now gives us f of x. Great. Okay, so to solve, when we've got like a fraction in a fraction, I think the easiest way to do this is to just multiply top and bottom by x minus 2 in this case. So what I'm going to do is I'm just going to write times x minus 2, and all of this, again, we want it to equal 4. So timesing by x minus 2 over x minus 2 doesn't change the value of the left-hand side, but it's going to rewrite it in a neater form. So 1 times x minus 2 on top is x minus 2. And now, timesing the yellow term here by x minus 2 will cancel out that denominator of the yellow. So it will leave us with just 1. And then we're minusing 2 lots of x minus 2. Okay, great. So we can now rewrite the bottom as 1 minus 2x, and then minus 2 times minus 2 is plus 4. Okay, so now we can say this is the same as 5 minus 2x, and we can then now multiply by this denominator to both sides. So it gives me x minus 2 is equal to 4 lots of 5 minus 2x. So x minus 2 is equal to 20 minus 8x. Add the 8x to both sides gives me 9x, add the 2 to both sides gives me 22. So x is equal to 22 over 9. Final answer. Lovely. Oops, I forgot to box that one up. Nice. Okay, lovely differentiation question here. I was very pleased with this one. We've got the curve with the equation y is equal to ax cubed plus bx squared minus 10, where a and b are constants. The point A has the coordinates 2, 2 and lies on C. Alright, that's some information that we can use. So the point A has the coordinates 2, 2 and it lies on C, which means if I sub 2, 2 into this, it should be good. It should hold because it lies on that curve. So let's sub in 2, 2. We get 2 for y is equal to, if x is 2, then x cubed is 8. So that's 8a plus x, 2 squared is 4, so that's 4b minus 10. So add 10 to both sides gives us this. We can divide both by 4 and we get this. Lovely. So let's that's not a final answer, but that is I've been boxing them all up in red, so I don't want to do that. Let's just box it up in orange because we're going to need to use that. Okay, now over to the next bit of information. It says the gradient of the curve at A is 4. Fine, so to find the gradient we need to take the derivative. So the derivative, 3 gets multiplied by a, becomes 3a, and then we drop the power down by 1. 2 gets multiplied by b to make 2b, and then we drop the power down by 1. And 10 is a constant, so that differentiates to 0. So what we're told is when we sub in the point A, which is 2, 2, we should get 4. So 4 for the gradient is equal, when we sub in x is 2. When x is 2, we're going to get 2 squared is 4 times 3 makes 12a. And then 2 times 2 is going to give me 4b. Okay, we can divide through by 4 to get this. And then we can box that up as well. And now we've got 2 equations for a and b, so we should be able to solve these simultaneously. So if I just write the previous one, the first one below this one, it's 3 is equal to 2a plus b. And if we subtract them, I get 1 minus 3, which is minus 2, is equal to 3 minus 2 is a, and then b minus b is 0. So that cancels out perfectly. So you get a is minus 2. So now subbing back into any of these two, let's pick this one. 1 is equal to 3a will be 3 times minus 2, so minus 6 plus b. Add the 6 over, we get this. So we've now got b and we've now got a. So we now know that y is equal to minus 2x cubed plus 7x squared minus 10. But in fact, we don't actually care about that because it says find the x-coordinates of C where the gradient is 8. So we only really care about dy by dx. So we want to work out the gradient, so we care about this. So let's write that one out again. So dy by dx, we know a is 2, minus 2. So 3 times minus 2 is minus 6. And then plus b is 7, so that 2 times 7 is 14x. And we want to work out the x-coordinate when the gradient equals 8. So let's move this over to that side and this over to that side. So when I move it over, it becomes a positive 6x squared. That becomes a negative 14x, and then we've got plus 8 there. That's great. We can divide through by 2 to get 3x squared minus 7x plus 4. So AC is equal to 3 times 4, which is 12, and B is equal to minus 7. So two numbers that times together to make 12 and add to make minus 7 are minus 3 and minus 4. So we can say 3, and I'm going to do it a different way this time to the question I did earlier. I'm going to use a different method. So I've got -3 and -4. And then we just put it all over 3. And that's good. So this gives me x minus 1 and 3x minus 4. So therefore x equals 1 and x equals 4 over 3. And if you want more practice doing quadratic equations quickly, then check out my my video on factorizing. Yeah, perfect. Okay, sequences, question 29. So the second term of an arithmetic sequence S is -5. So we know that the nth term is equal to a plus n minus 1 d. So that's an equation you're not given in your formula sheet, so you should remember that one. So if we're looking for the second term, that's a2, which is equal to a plus, if n is 2, because it's the second term, 2 minus 1 is just 1, so just 1d. And we're told that's equal to -5. And then it says the seventh term is 10. So a7 is equal to a plus, if n is 7, then 7 minus 1 is 6, so 6d, and that's equal to 10. Okay, great. So we can just straight away solve this simultaneously to work out a and d. So a minus a is 0, that cancels. D minus 6d is -5d. And -5 minus 10 is -15. So dividing through by -5, we get d is 3. So subbing back into this top one here, we get a plus 3 is equal to -5. So subtract 3 from both sides, we get a is equal to -8. Okay, so that's good. We've used those first two lines of information. Now we can read the rest of the question. The sum of the first n terms of an arithmetic sequence is 350 less than the sum of the first n plus 5 terms. Find the value of n. Okay. The sum of the first n plus 5 terms is bigger because the sum of the first n is 350 less than. So if we do the sum of the first n plus 5 terms, it will be n plus 5 over 2, because the summation formula, let's just remind ourselves, is n over 2, 2a plus n minus 1d. That one is given. So this will be n plus 5 over 2, open brackets, 2 times a, and a is -8, so that's -16, plus n plus 5 minus 1 d. And if we take that and then minus n terms, we should get 350. So if I do the sum of the n terms, it's n over 2. 2a is again -16, plus n minus 1 d. And that should give us 350. Okay. Great. Now we just need to do some simplifying. So in fact, what we could do is we can actually times the whole equation through by 2, which will make this 700 on the left side, and it will cancel the 2's here because those are divided by 2's. So we get n plus 5. Now what's inside this bracket here? Let's work this out carefully. Oh, d, we know d. We should have put that in as 3. So times by 3. Okay, so we've got 3n. This is 4, which then gets times by 3 to make 12, and then -16 gives us -4. Here we've got n times again, that's going to be 3n. That's going to be minus 3 and minus 16, so minus 19. Okay, great. Let's expand out these brackets to get 3n squared minus 4n plus 15n minus 20. Let's multiply this to get minus 3n squared. Be careful of the double negatives, so that's plus 19n. Okay, we've got a 3n squared and a minus 3n squared, so that's quite handy. So it's not going to be quadratic. So we've got minus 4 plus 15 is 11, plus 19 is 30n, and then we've got minus 20 there. So add 20 to both sides, and then divide through by 30 is going to give us 24. So that is perfect. That's exactly what we wanted. Shown clear algebraic working, got the final answer. Lovely, lovely, lovely. Okay, what paper would not be complete without a vector question? Alright, we've got OAC and ACB are triangles. D is the point on AC such that ODB is a straight line. So you thought these questions were hard, well, making them is also hard. So what I like to do is label all of the information on the diagram. So that is 2A going in that direction. That is B going in that direction. And A to B is 5A plus 2B going in that direction. Okay, great. It's asking us to find this ratio OD to OB. So if I just draw that straight line on ODB like so, then that ratio is across this line. So I'm going to colour that line in yellow. And in fact, OD is what I'm going to want to try and find in two ways. So I'm going to want to find it once with a yellow root and once with a blue root. So first, let's go for the yellow. So for the yellow, we have O to B is the yellow line. So O to B, we can get there by going this way, there, and then there. So that is 2A plus 5A plus 2B, which is 7A plus 2B. So then O to D is a fraction of that line, so I'm going to call it lambda is the fraction, and then we're going to multiply it by that line. So we're going to take a fraction of the whole line, and that's going to give us O to D. Great, and I'll just colour that in yellow because I've used the yellow line to get there. Now we're going to look at the blue line, which is A to C. Now to get from A to C, I could go minus 2A, because it's against the arrow, and then plus A. So that's minus 2A, sorry, let's say that again. Minus 2A against the arrow, and then plus B to get down there. So that's plus B. Okay, great. Now, in fact, what I want is just A to D, because I want to get to D, and that is going to be a fraction of the overall blue line AC. And now this allows me to write O to D using the blue root. So how am I going to do that? Well, I'm going to go from here up to here, and then I'm going to use AD. So I'm going to do 2A plus AD, which is what we've just worked out, mu minus 2A plus B. Cracking. So now we are good because we have two expressions for OD, one using the yellow, one using the blue, and we just equate them. So I'm going to equate them, and I'm also going to multiply out the brackets and I'm going to write the a's and the b's at the end of each expression, each term. So 7 lambda a plus 2 lambda b, so that's this one expanded out, is going to equal 2a minus 2 mu a plus mu b. Brilliant. Now I'm just going to look at the a's, because the a's and the b's must be equated. Because these two things are the same, O and D, they're both O to D, they must have the same a's and the same b's. So the a's on the left, 7 lambda, is equal to the a's on the right, which is 2 minus 2 mu. And the b's on the left, which is 2 lambda, is equal to the b's on the right, which is just mu. Okay, now what I do at this stage is I have a quick check and figure out, do I need to solve for lambda or mu? I could do both, but I only need one. I need this ratio here, which is on the yellow line. And the yellow line was split up by a fraction, and that fraction was lambda. So I only need to find lambda, which means I need to eliminate mu. So I'm going to pick up this mu, and I'm going to plonk it in here. So this becomes 7 lambda is equal to 2 minus 2 lots of the mu I'm going to swap out for 2 lambda. And now I've got an equation just in terms of lambda. I can solve this for lambda. I get 2 minus 4 lambda. Add the 4 lambda to both sides. Gives us this. Divide through. And I get this. Perfect. Okay. So now I can go back up to the top, and this was 2, so lambda again was the fraction of the overall line, the yellow line, which takes us from O to D. So that part is 2/11, which means this part is 9/11. So the overall ratio OD to DB is 2/11 to 9/11, which is of course just 2 to 9. So that is the final answer. Right, if you enjoyed that, then consider, please, signing up to my live sessions. It really helps support the channel, helps me continue doing what I love doing, which is teaching maths online and helping people pass their exams. What you'll get is 2 more of the papers that I've created. You won't be able to find them anywhere else. And you'll get a live session with me where I go through those 2 papers and any other questions that we don't have time to complete, then I will do video solutions for, which again will be sent out to you. So check it out, link in the description, and I wish you all the best in your exams. Bye for now.